So welcome to this is the Further Math Support Programme online revision session for MEIS 2, and in this session we're going to be looking at regression. So regression is the ability to find the equation of a line of best fit for the data that you're given, and you can only really find regression lines when you're convinced that your data is linearly correlated or fits a line effectively. Now you can always do the calculations, but it only makes sense to do so if your data fits a good straight line. So usually with questions they may ask you to justify that in the first place. We also need to understand things like independent variable, dependent variable, and we need to be able to identify them. We also need to be able to use your model to predict and also understand the concept of something called residuals and interpret these things called residuals, which we'll look at when we get there. So January 10, question 1, we've got a pilot and he's going to record the takeoff distances for his light aircraft on a runway. The data are shown in the table below, where A is meters in altitude and T is takeoff distance, and we're given the summary statistics as well. So before we draw a scattergraph of this, we need to understand a few things. We need to understand which way round my axes need to go. Now there is a hint later in the question, which I'll talk about when we get there, but it's worth thinking about now. Now basically what the pilot is able to do is, if I want to achieve an altitude of 900 meters, for instance, I am going to need a takeoff distance of 836. So in other words, the pilot to some extent has control over the altitude he wishes to reach. T, which is the takeoff distance, is controlled is responding to that altitude. In other words, it's dependent upon that altitude. So as a consequence, A is going to be what we call your independent, T is going to be your dependent variable. As a consequence, that tells you which way round they go on the axes. So A must go on the horizontal axis, T must go on the vertical axis. Okay, so we get 3 marks for this. You basically get 2 graph marks for plotting the points, and you get another graph mark for labeling and stating your axes correctly. So we're then asked to state which of the 2 variables are independent and dependent. Well, we've discussed that already, so let's just formalize that. So A is independent and T is dependent. And the fundamental reason is that the pilot controls A. Okay, he chooses it. Whereas T is dependent upon the value of A. It responds to it. Okay, so this is why sometimes A is called a control variable and T is sometimes called a response variable. Okay, so we're then asked to calculate the regression line. Now, it's quite nice. In the formula booklet, you're given an equation for the regression line y on x. So here it tells you which way round your axis must go. So this is what I was saying about there being a little hint in the question as to which way round your scattergraph needs to go. Okay, so in the formula booklet, you've got an equation that says y is equal to bx plus a, where b is equal to sxy over sxx, and a is equal to y bar minus bx bar. So what we are required to do is, before we use this, and I advise you to do this strongly, is to put this into correct context. So this should be t is equal to b a plus, I've already used a, so let's call it c now, where b in this case is going to be SAT over SAA, and a, or c as it's your y-intercept in this case, is going to equal t bar minus ba bar. So to do this we need some calculations. We need to know what a bar, t bar, SAT and SAA are. Okay, so a bar is going to be the sum of a over n, which is 6300 over 7, 900. And we also need to know what t bar is, which is going to be the sum of t over n, which is 5987 over 7, which is going to give me 855.2. So we then need to be able to work out SAT. So SAT is equal to sum of AT minus the sum of A, sum of T over N. So I'll calculate this one. 6037800 minus 5987 times by 6300 over 7, and that's going to have a value of 649500. If you do the same for SAA, using the same idea, was it sum A squared minus sum of A squared over N, that's going to give you a value of 2520000. So therefore, just putting the regression model all together now, I'll do this in the bottom corner, we've then got B is equal to 649500 over 2520000, which is 0.258, and then we use that to find the y-intercept C. So C is going to equal T bar, so it's 855.2 minus B, 0.258, times by A bar, 900. Please make sure you get all of these the correct way around. You can lose lots of marks very quickly if you're not careful, which is going to give me 623. Okay, so your regressional model is now going to be T. T, let's ignore him, is equal to 0.258 A plus 623. Okay, so let me change my pen and show you where your marks are awarded here. So you've got 5 marks in total for this. You're going to get, over here, you're going to get a B mark for working out your means correctly. You're going to get a method mark for some attempt at working out your gradient. Okay, and that can be awarded for lots of things. You get your A mark for getting the correct gradient. You then get a method mark for attempting to work out the constant, and your final accuracy mark for getting your line of best fit correct, your regression line correct. Okay, so coming back to the question, it says use your regression line, so I'll just state that again. So regression line is T is equal to 0.258A plus 623. So use your regression line to work each of these out, and comment on the reliability in each case. So let's talk about the reliability first of all. Now let's look at 800. If you go back to your data, 800 is within your data set. Okay, we are looking only at the response variable, but 800 is within your data set, so here we are interpolating. That is reliable. Okay, so that's allowed. 2500 is outside of your data set for your control variable, so we call that extrapolation. Now you're only really allowed to extrapolate slightly out of your data. Here, this is quite a distance away, so we would have little reliability in B. Okay, so that's the sort of reliability arguments discussed. So let's do the predictions now. So all we need to do is to substitute into your model the value. So 0.258 times by 800 plus 623, which is going to give me 829, and B, substitute in 2500, so 258 times by 2500 plus 623 is going to give me 1268. So again, the first one is reliable because we're interpolating, so A, reliable since interpolating, and B is not reliable since extrapolating. Now again, if you were looking at 1900 or something like that, then you could probably say it is less reliable rather than not reliable because it's only slightly out of the comfort zone, as it were. Okay, and you get a mark for each of those. So here, a pilot records takeoff distance, same question, we've got the data now, and the model has been used to create this point. Okay, and what we've got to do, sorry, that's the point given, and we've got to work out the residual for the data point. Okay, so what we do is we use the value of A here in the model to get what we call the predicted value. Okay, so we've got T is equal to, let's write the model again, 0.258 A plus 623 So we work that out, 0.258 times 1200 plus 623. So that's going to give me a value of 933. Okay, so the residual, we sometimes use the symbol epsilon, so the residual of this point is equal to the actual value minus the predicted value. So sometimes this is called y hat as a predicted value. So we do y minus y hat effectively, which is 923 minus 933. So you have a residual of minus 10. Okay, so we'll just talk about commenting on the sign in a minute. But here you're going to get 1 mark for the prediction. Okay, you're going to get 1 mark for doing the subtraction, i.e. finding the residual, and you get an accuracy mark for getting it correct. Now it says comment on the sign. Well, the sign's negative. All that really means is that the observed value 923 is below, on your graph, it's below your predicted value. So epsilon negative implies that the observed value is below the predicted value. That's all we need to worry about. Okay, so you'll find most of your, and that's a final E mark there. So you find that covers all of your regressional needs effectively, and their questions don't really differ too much from that.